Okay guys, today we're going to talk about some perimeters and areas within the coordinate plane, and then we're going to do a coordinate proof as well. So for this first one, it says find the perimeter and area of the figure. Round decimal answers to the nearest tenth of a unit. So to find the perimeter, we have to add the sides. So to do that, we need to find the length of those sides. So we're going to need to use distance formula. Now one really nice thing is that I know since it's a rectangle, I know opposite sides are going to be congruent to each other. So I could find just the length of CD, and I know that it should be equal to the length of AB. So point C is 1, 2, 3, 4, 5, 6, and up 1. Point D is 1, 2, 3, 4, 5, and up 3. So I'm going to subtract my x values and square them. And then I'm going to subtract my y values and square them. So I get -1 squared, and then I have 2 squared. So -1 squared is +1, 2 squared is 4. So I get the square root of 5. So when we type the square root of 5 in our calculator, we get approximately 2.2 if we're rounding to the nearest tenth. All right, and then if we look at AD, A is 1, 1, because I know that the length of AD should be the same as the length of BC, I can subtract 5 minus 1 and square it, and then 3 minus 1 and square it. So 5 minus 1 is 4, and then 3 minus 1 is 2. So 4 squared is 16, 2 squared is 4. I get the square root of 20. And so I could simplify that, but since it's just asking for the decimal answer, I just put it right in the calculator and I get about 4.5. Okay, so perimeter tells me I'm going to add the sides. So I have 2.2 plus 4.5 plus another side length of 2.2 plus another side length of 4.5. So I get the perimeter to be about 13.4, and since we don't have a unit listed, we'll say units. Area is length times width for a rectangle, so we're going to take our 2.2 and multiply it by 4.5. So we get approximately 9.9, and we'll say units squared. Anytime we're talking area, we square the units. Okay, so now it also wants us to find the perimeter and the area of this triangle. So, finding the perimeter, I know one nice thing is that I can see the length of EF just by counting 1, 2, 3, 4, 5 is the length of EF. Now I'm going to have to find the length of EG using that same distance formula. So E is at -2 and up 3. G is at 1, -3, and F is at 3, 3. I'll go ahead and fill that in while we're at this. So I'm going to find EG first. So I'm going to subtract the x values. So 1 minus the -2 squared plus, and then I need to do -3 minus 3 squared. So 1 minus -2 is 3. I'm squaring it. -3 minus 3 is -6, and I'm squaring that. So 3 squared is 9. -6 squared is 36. the square root of 45. Again, I'm going to go ahead and instead of simplifying, I'm just going to put it right in the calculator, and I get about 6.7. So then I need to find the length of FG. So I'm going to subtract the x value, so I get 3 minus 1. We need to square that. And then the y values are 3 minus a negative 3. And square that. So I get 2 squared plus 6 squared. So I have 4 plus 36, which is the square root of 40, which is approximately 6.3. Okay, so for perimeter, I have 5 plus 6.7 plus 6.3. So I get approximately 18 units. Now for area, it's base times height divided by 2, or half of our base times height. Well, our base is this length of 5. The height of the triangle isn't either of the values we found. It's actually coming from point G to the other side. And since that's a vertical line, I can count the boxes. 2, 3, 4, 5, 6 boxes. So I have 5 times 6 over 2, which is 30 over 2, which is 15, and we'll say units squared. So you'll have some of those to practice on your practice problems. Now the last piece says, prove that the diagonals of a square bisect each other. So the way in which we do this is we have to come up with a coordinate plane where this square would be. So I'm going to draw out, and I'm going to put it in the first quadrant just because that's easiest, I think. So one thing I know about a square is that the side lengths are the same, but I don't know what those side lengths are. So I have to give it a value. I have to give it a variable there. So I think it's easiest if I start at 0, 0, because then I know where that point is. That does have a numerical value. Now I'm going to go over, if I say that this has a length of A, then I have gone to the right a distance of A, and I haven't moved up or down. I'm going to call that point B. I'm going to skip over point C for a second. For point D, I know it has a length of A, so I haven't moved left or right, but I have moved up a length of A. Now if you think about it, if we're talking about a square, we've moved right A and we've moved up A to get to point C. So I'm going to draw this in a different color so you can see this square. So there's my square in the picture. Now to prove that the diagonals bisect each other, we want to show that those diagonals cut at the midpoint right there. So we need to find the midpoint of each of those diagonals. So we're going to find the midpoint of AC. So remember that our midpoint, we add the values and we divide by 2. So I'm going to add the x values, 0 plus A, and I'm going to divide by 2. And I'm going to add the y values, 0 plus A, and divide by 2. So I get A over 2 and A over 2. And I'm finished with that one. Then I have the midpoint of my other diagonal, which is BD. So I have 0 plus a, and I divide that by 2. And then I have a plus 0, and I divide that by 2. So I end up with a over 2 and a over 2. And since we have the same midpoint, we know that they have cut each other in half. So we could say the diagonals have the same midpoint and therefore bisect each other. Alright guys, that's it for this chapter. If you have questions, please come in and see me. I'll see you in class.